Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic length. And for this lesson, we're going to cover some concept called significant figures. So we want to see what it means when you talk about significant figures. What does it mean in simple terms? So that is what you want to discuss. So the lesson will start by possibly trying to find the meaning of significant figures. And then we will have some few questions on significant figures. We'll have some assignments at the end of the lesson, and of course, that will help you check whether you've understood the concept or possibly you really need to go through it again and again to get to understand the concept better. So what does it mean? Significant figures, what does it mean? So significant figures are the numbers we say the number of digits in a given value, often measurement that contribute to the degree of accuracy of the value. So the accuracy with which we state or write the measurements may depend on its relative size. So for example, if you talk of a number like 0.2 here, so which digits are significant? So when you say maybe 2 is one significant figure, you see, one significant figure. So in this case, we are only interested in this. So here the question is whether 0 is significant or not. So we have three ways or three positions that 0 can occupy. That will determine whether it's going to be significant within a given number or not. So we have the zeros we call leading zeros. These are the zeros before, like these ones here you can see. And then we have trailing zeros. And then, of course, we have middle zeros. So the trailing zeros are like you have something like 20400, you see these ones. The zeros on the right hand side of the last non-zero digit, like 4. So these zeros here, we call them trailing zeros. And then we have middle zeros, the ones that are appearing between two non-zero digits. Two non-zero digits. Like this one here, we call it middle zero. So these three will determine whether the zeros are significant or not, and we're going to see how important that is. So whether the zeros we're having are leading zeros, that is on the left of the first non-zero digit, or they're trailing zeros or they're middle zeros. So what we say now, 0. Of course, we say all non-zero digits are significant in a given number. For example, we say all the natural digits are significant. For example, you have 204. You see these 4 and 2, they are significant, all non-zero digits, they are. So the question is whether 0 is significant or not. So that will depend on whether it is the leading zeros, trailing zeros, or middle zeros. So all the middle zeros are usually significant in a number. You see, significant in a number. They are significant, like this one here. This is significant, and you're going to see how we count the significant number of significant figures. Now, leading zeros, they are never significant. Like these zeros appearing before, they are never significant. For example, if you have 0.023, these ones here, the leading zeros, no. Now, trailing zeros, the question is on trailing zeros. So we have said now, leading zeros not significant, middle zeros significant, trailing zeros may or may not. So trailing zeros, if you have a number written like 200, then these ones here, these last zeros here, we say it's an ambiguous case. You'll not be able to tell whether they are significant, these last zeros here or not. But when you have something like 200 and then you see a decimal point, then now these ones are important. These are important. These ones are important. Now, this zero here are these two zeros here are significant. They are going to be significant just by the virtue of having the decimal point. So every time you have a decimal point, when there is a decimal point, then the trailing zeros become significant. They're significant. So in what sense? That basically tells you the degree of accuracy that is required. For example, if this was to be centimeters and then you end up converting this to meters, what will you do? You will multiply this by, or you'll divide this by 100 so that you'll end up with 200 divided by 100. This will shift the decimal point from here, 1, 2, you see. So what will you end up with? 2.00. So it means the accuracy that is required is up to the second decimal place. So you'll have to state the number that way, you see. That's the essence of significant figures, So in trying to convert that number, you may not, you'll have to maybe include the 2 zeros. Sorry. The level of accuracy or the level of precision that is required. Yes. Look at something like 0.002 or 0.002. 0.002. So you see here, only this one here. You see, these leading zeros are not significant. So we'll only go for this. So if, let's say, this was a meter, or let's say this is a kilometer. So you want to convert this to what? To meters. You'll have to multiply by 1,000. So you'll have 0.002 multiplied by 1,000. So what do you get? 2. So you just write 2 what? 2 meters. You see? So the first zeros there are not really important, It is a different case when you had a number written like 0.000200. So you see we have leading zeros and we have trailing zeros. So in this case, because of the decimal point, the trailing zeros are now important. So supposedly this was maybe kilometers, and you are trying to convert it to meters, the 0.00. So you have to multiply by 1,000. So you have 0.00200 times 1,000. So you see, we talk about these last two zeros are significant because of the decimal point, That again communicates to level of accuracy or precision that is required. So multiplying by 1,000 will give us 2.00 meters. You see, we have multiplied. So the first, the leading zeros here, we have not really considered them. We have only considered the other one. So this is the required level of accuracy for this number. So if there is a decimal point, the trailing zeros are important. Of course, we have said all non-zero digits are significant. The middle zeros are significant. So you see, there are 3 ways in which zero can appear in a number. It can be a leading zero, a trailing zero, or a middle zero. So all non-zero digits significant. See, middle zeros significant. Trailing zeros are significant if there is a decimal point. So please take note. So trailing zeros are only significant if there is a decimal point. Leading zeros are never significant. So that one is obvious. So we want to express the number 90. So we have 9063152. How many significant figures? 3. See, 3. So significant figures will count from the first non-zero digit from left as you move to the right. So we want 1, 2, 3. Draw the cutoff line. Check the digit after the cutoff line, just like we did the number of decimal places. So check the digit after the cutoff line if it is 5 or more or upper category. Remember upper category numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So upper category, lower category. So if the digit after the cutoff line falls in the upper category, increase the digit before the cutoff line by 1. If the digit after the cutoff line falls in the lower category, leave the digit after the cutoff line the way the digit before the cutoff line the way it is, and of course, all the digits after the cutoff line will always reduce to zeros, just like we did it when we are talking about decimal places. So we have 9066. Nothing happens to 6 because the digit 3 is not in the upper category. And of course, the digits after the cutoff line will reduce to zeros. So this is how many significant figures? 3 significant figures. You see? So 906 are thousands, 3 significant figures. So again, we have this here, you count just the same way we did the previous one. So we count the significant figures, we still count from left as you move to the right. So 1, 2, 3, we draw the cutoff line. Look at the digit after the cutoff line. Does it fall in the upper category or lower category? So 0 falls in the lower category. Remember 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this is lower category group of numbers. The other one is upper category group of numbers from 5 to 9. So upper category, you increase the digit before the cutoff line by 1. Lower category, nothing happens to the digit before the cutoff line. And of course, in all the cases, we reduce the digits of the cutoff line to zeros. So we have 400, 000. You indicate 3 decimal places. 3 significant figures. So in this case, only the first 2 zeros are significant, the rest are not. So again, we have this. We'll count from the first non-zero digit after the leading zeros. So we have 1, 2, 3. Draw the cutoff line. 7 falls in the upper category, so we increase 6 by 1. So 0.08570. So remember, this is a decimal point. So if you leave it this way, remember these 2 zeros will be significant. Why? Because there is a decimal point. Remember we said now the trailing zeros are significant as long as there is a decimal point. So what do? You have to go back to what we said previously, that the last zeros are the decimal point. They never count that much. So you ignore them. So you indicate 3 significant figures. So please take note, we have counted the significant figures from the first non-zero digit, which is 8. That is from the left. Again, this approximately will be 156. 0, 0, it will remain to 3 significant figures. 1, 2, 3. So the last 3 zeros are not significant. And of course, we have a few questions here to help you practice on what significant figures are all about. So here you are supposed to express the following numbers to 2 significant figures. So you can always attempt, post the response in the comment section. We'll be able to look at them and give feedback in the due course. Otherwise, that marks the end of the lesson. Until next time.